Okay, so we'll now move from left to right across the ribbon once again. This FEA is a static analysis, single point, and we've also looked at the other option, which was parametric dimensioning. So that's the two options we had. We also have contacts here of tolerance of 0.1 and bonded, so that means we'll find anything within 0.1 and glue it together. We'll come back to the contacts in a moment. So we won't be doing parametric on this one. We'll just go over that, the materials. So once again, materials that come through from the model. This one here has some default materials. Default has no properties, so we need to change that, otherwise we can't do any simulation on it. So those three parts are the same, so they will change at the same time. So I'm going to make these mild steel, and I'll make a couple of others high strength steel. Okay, so we can see in the browser here that the material overrides properties shown in the browser, so we can see exactly what we changed here. We can change any of the components here, so we can override any materials that comes from the model. Now we move to the constraints. I've already had some constraints on here, which is on the bushes. The whole platen is still free to move up and down. As I'm putting the loads on from the bottom, I'll put a constraint on top of the piston, so the piston can't move up, and I'll put the loads coming from the bottom. So this is a fixed constraint, and once I've selected that, I can either select points or I can select edges. So I select the top of the piston. So now we have our two constraints. As I said, I've already put some loads on here. We have a number of different loads, pressure, bearing loads, gravity load, as well as moments. I'm just using simple force. Once again, I can select edges, points, or faces. I'll select this face, and because of the face, it's going to put the force on normal or perpendicular to the face. So I won't need to put in a direction, I'll just put in a load. Okay, so once I've had my loads, move on to the contacts. And I think it's pretty cool that we can say, okay, we've got a default contact of 0.1. We'll just hit the automatic and go through very quickly, look for anything that's within 0.1 of each other and create default bonded contact. And there it's done. So now we have all our bonded contacts here. Now, obviously the bushes and the guide rods need to slide. So once we have our default contacts, we come through here, and because I added these bushes as the last component, they actually turned up at the bottom, which is very handy for me. I can select those ones and say edit the contact to change it to one of the others. And we have a number of options here, including the spring and separation, which basically means they can just separate again. I'm going to choose the sliding no separation for these bushes. So now we can see our different contacts in our browser, and we can strip the browsing over and we can see exactly which ones we've changed. So we can also add manual contacts, so if we had things a little distance apart and we want to put a spring in between them, we can select the faces and put a contact there. So we'll go to our meshing. I'm going to use default meshing and we'll put in curved mesh elements because it does give a more accurate result. And also look at the local mesh control. So we can select edges or faces to change the mesh. I'm going to select the top face of the piston and put in large mesh. because I consider that the top base of the piston won't be affected in this simulation, so I can get away with fairly large stress, large mesh. If I was interested in some good feature, I might decide to put a very small mesh on there manually. So now we'll mesh it, and as I said, it'll mesh the small components with small mesh and the large components with large mesh, which is quite important. If it was all the same, then of course the small components have a very large coarse mesh, and that would give a poor result. We've got putting it down, here 105 components here, so take a few seconds.
You're about 5 minutes.
5 minutes?
Yeah.
When you set your separation, you call it bonded. You have other options besides bonded.
Yes, we do.
Yeah,
So I showed those here, there's the spring and the...
yeah I work with gaps between faces, but I don't want them to act as bonded. I just want them to move but not penetrate. It's called penetration. They're bonded but no penetration. So, I mean, they're staying parallel. If you move one, it moves. We don't want that. I want that to happen.
So it moves, and then once it touches, it stops.
Once it touches, it doesn't penetrate.
No.
Does that give you the option?
No, this doesn't give you the option.
So it's just bonded.
Yeah, bonded or separation. Okay, so we have the mesh here. We'll see we've already looked at the refinements of the simulation, so we'll move straight on to the simulation. Actually, I won't destroy it, we'll show the mesh first. See, we've got this small mesh is on the small components and large components. And so we'll simulate this. Once again, it's really processor power here is the main important factor. This is the CPU jump function. So that it'll just how fast the processor you have is how quick this solves. This PC, to give you an idea, it's a 2.4 gigahertz processor, dual core, and the laptop has 4 gig of RAM, half the spring stolen by the video card, so we've only spent half included. There's no problem with the RAM here, it's simply processor power. Away it goes. Always seems to take longer. Almost there. Well, it's only once also we can actually do our emails or other things. It's running. Almost.